Okay, this is the practice final exam your instructor gave you, and I know you said don't worry about it because you work through these in class, but sort of fun, so I thought I'd talk through them, if not work them through. So this first one is just a good old-fashioned basic present value problem where you have to calculate the cash flows and then discount them back to present value. So the discount rate is going to be 12%, but of course first you have to get all the cash flows. And so you've got a negative $90,000 cash flow at year zero, I would call it, at the very beginning of the period, and a $10,000 investment in working capital. So at T equals zero, you've got $100,000 going out, and that's, since it's at the very beginning of the project, it's not discounted, so the present value is also the $100,000. It's expected to produce revenues of $120,000. That's costs are going to be manufacturing costs, be cost of goods sold. Some people would call it 60%, so that means 40% gross margin. So if you take the $120,000 times the 40% gross margin, that's 48%. I mean, it's $480,000 of gross margin on the project. So 48,000 gross margin. Then the equipment, not the working capital. You can't depreciate working capital, but the equipment, it says, is depreciated straight line over how many years? 3 years. I'm going to assume, since it says for 3 years, maybe. It doesn't say how many years, but I would assume since the project's 3 years, you depreciate the $90,000 equipment for 3 years. So you have depreciation, which is a non-cash cost, but it does reduces your taxes, and has zero salvage value at the end. So there's no, at the end you sell the equipment and there's some kind of capital gain at the end. This is sort of unusual. It says zero salvage value at the end, but then it says the firm can sell the equipment at the end for $10,000. To me, that's a little inconsistent. So in just that final period, the end of year 3, you would have this one-time $10,000 cash flow. And the tax rate's 30%, so the taxable income from the project, there's no mention of debt here, is going to be the $18,000 times 30%, so that's the tax. But remember, depreciation is a non-tax expense, so you would just subtract the tax from the $48,000 gross margin. So that gives you, I think, a $30,000 cash flow in years 1, 2, and 3, after-tax cash flow. And then in year 3, you also have this $10,000, which you would want to compute the tax on that too. So I think that would be, since you fully depreciate the equipment, you'd have a $10,000 gain, and you'd apply the 30% tax rate. So the after-tax gain on that's $7,000. And I think what they mean here by salvage value is meaning you depreciate the assets down to a value of 0 over the 3 years. Okay, so that's that one. So problem 2 here appears to me at first glance to be identical to problem 1, except they're asking you to only calculate the cash flow of the project in year 3 only. In other words, this one, to get a net present value, you would need to calculate problem number 1 up here, you would need to calculate the cash flow for all 3 years and then discount it to present value. This looks to me to be just a much simpler, it's not asking you for a present value, so the discount rate is not, is irrelevant. So, I think all the other numbers are the same as problem number 1. So if you have a gross margin in year 3 of $48,000 and you got the $10,000 gain on sale, so you got $58,000 of earnings before taxes or taxable income. So your taxes, forgot the depreciation, which is very important. So that does total up to $58,000, but you've got a $30,000 of depreciation, which is a non-cash expense. So it leaves you $28,000 of taxable income. So earnings before taxes. This would be probably called operating income, something like that. So you just compute, so that's your earnings before taxes. So you take 30% of that, 28,000 times 0.3, it's 8,004. So your taxes are 8,400. Now to get cash flow, remember depreciation's non-cash. So you would take your 58,000, because these are both cash numbers, the gain before tax and the gross margins before tax. You'd take the 58,000, subtract the 8,400. So let's see, if 58,000 subtract the 8,400, let's see if that comes out to be one of these answers. Yeah, it does. So I think it's that one. So problem 3 here, looks to me that what they're trying to get at here is just a simple application of the perpetuity growth formula. You've got a project, requires $900,000 investment today, so that's not discounted. It's because it's at time 0. It has $1,100 per year forever, so that is where they're sending you the signal, use the perpetuity growth formula. Costs will be $600 in the first year and increase by 20% a year. You can stop production at any time, calculate the net present value. I think I see why this maybe is not actually the perpetuity growth formula. Because if costs increase start at 600 and increase by 20% a year, then eventually the costs are going to exceed $1,100, and that's why they say you can stop production anytime. So the smart thing to do here would be to in year 1, you've got a $300 cash flow. It says ignore taxes. And you invested $900, so obviously you're getting more than your 12% return. You're getting a 33% return. So I think the trick here would be to just put this in a spreadsheet and take it out to the point. At first glance, I thought you'd take it out to the point where the cost exceed the $1,100 in sales, and then you just stop it there, and whatever that point is, discount it all back to present value. And I think I'll do that and see if it comes out to be any of these. There also might be a rationale for taking it out to the point where you're no longer getting the 12% return. So but I think it's probably smarter to take it out to where it's producing negative cash flow, because if it's a little bit positive, that's additive to the net. That's additive to the net present value, even if it's just $1 positive. So yeah, I think you'd take it out to the point where the 600. Let's just say if it grows by 20% a year, let's say for 5 years. Just guessing here, times 1.2 raised to the 5th, which is 2.48 times 600. So that's 1492. So it looks like you're only going to go out 3 or 4 years before you'll have a loss, and then you would discontinue the project.